Hello guys, this is a video solution to tutorial sheet 10. Right, so I will go through every single question. There are 5 questions in the sheet and give you a detailed solution. Right, so let's start with the first one. So you have a random sample from a binomial with parameters 1 and 3 and an approximate 100 times 1 minus alpha confidence interval for P is this one. Let's discuss it in the notes. The first part is to derive the width of the confidence interval. Right, so let's see how we can do this. So you have the confidence interval for P is x bar. I mean, in using the notation I had used in my lectures and also in the video. This is what I used: x bar plus or minus z 1 minus alpha by 2, x bar times 1 minus x bar divided by n, everything square root. Right, so you may recall this from the videos. Right, this is the formula I gave you for the confidence 100 times 1 minus alpha confidence interval for P. Right, now we want to find the width. The width is clearly the difference between the upper limit, which is this is the upper limit, right, minus the lower limit, which is okay. So if you compute this, this will be 2 times right, so this is the width of the confidence interval. By the way, here x bar denotes the sample proportion, right? Okay, not to be confused with the sample mean, right? Okay, now clearly this is proportional. This is the sign which denotes proportional to the standard error, which is this. Okay. So that's what the question asks you to do in the first part. The second part is asking you to plot this as a function of P. So part 2, let Vp is equal to P times 1 minus P. I'm sure you guys know how to plot functions. I mean, this is stuff you should have, what you learned in calculus in semester 1, and you probably know better than I do, right, how to plot functions. Okay, to plot function, basically the first thing you need to do is to take the derivative, right, with respect to P. That will give you 1 minus 2P. Set this to 0, solve for P, you get P equal to half. Now to check whether this is a global minimum or global maximum, you take the second order derivative, which is minus 2, right, which is less than 0. So what this suggests is that P Okay, so the function attains its global maximum at p equal to half. Furthermore, if you put p equal to half into the function, you get half times 1 minus half, which is a quarter. So the largest possible value of the function is a quarter. And the value of the function at p equal to 0 is clearly 0, and the value of the function at p equal to 1 is also 0. Right? So given all these details, you should now be able to graph the function, right? And if you do that, this is what you will get. It will look like this. So it is, as you can see, it is 0 at 0, 0 at 1, and at half it takes the value quarter. So this is the value. So when p equal to half, okay, which is this point here, right? This is p equal to half. You get the largest value of the function at 0.25, which is quarter, right? Okay, so that completes part 2. Part 3 is confirm algebraically that Vp is maximized when p equal to half and states its maximum value. We already done that. So going back, we have already done part 2 and part 3. Okay, now part 4, find an upper bound for the width of the 95% confidence interval when n equal to 1000. Right, so alright, so let's go to part 4. Remember the width of the confidence interval, let me write it down one more time, is this is the width of the confidence interval, right? So we are looking for alpha equal to, 100 times 1 minus alpha is 95, so your alpha will be 0.05. So you're looking at z 0.975 times this divided by n is 1000. Okay, now if you read this of the table, now for the normal distribution, this will be 2.196 multiplied by right now. We know from the previous part, that is part 2 and part 3, that the largest possible value for this is a quarter. So this must be bounded about by this, right? Alright, so now if you simplify this, right, you will get this is equal to 0.062. Alright, so that's the upper bound for the width. Okay, so that completes question 1 of sheet 10. Now question 2. We have 2 brands with the sample size of 150. The first brand has a mean of this and a standard deviation of this. The second brand has the mean of this and the standard deviation of this. Okay. So the second brand has 200, a sample of 200 with the mean of this and the standard deviation of 98. And we want to find a 95% confidence interval for the difference in mean lifetimes. So first part is to assume that the variances are not equal. The second part is to assume that they are equal. Right? Okay. So let's see how we can do this. Before we start, let's write down what we are given, right? So let NA denote the sample size, the first sample size, which is 150, right? And NB denotes the second sample size, which is 200. And let this denote the sample mean for the first sample, which is 1386. For the second sample, it is and we are also given the standard deviation, which is sigma A equal to 114 and sigma B equal to 98. So given all this, and for the first part, we want to find 100 times 95%. Okay, but let me first write down the general formula, which you should remember. So 100 times this confidence interval for the difference in the population means is the following. Okay, so this is the formula. You should look in the notes, or you should look in the video on confidence on two sample confidence interval. You will see this formula. So to do the first part, we just need to simply apply this formula, right? So it will be. Alright, this is the sample mean for the first sample, which is 1386 minus 1218 plus or minus. We are looking for 95%, so this will be 0.975 114 squared divided by 150 plus Alright, now if you read this off the table, you will get 1.96, so this is okay. So you should compute this using a calculator. This is what you will get. The lower limit will be 145.26. The upper limit will be 190.74. Alright, so that completes part 1 of question 2. Now to do part 2, we need to assume that the variances are equal, right? Alright, so in this case we need to use a formula, a different formula that we learned in the course, right? I will write it down in a second. When the variances are equal, or assumed to be equal, so this is question 2, part 2. The 100 times 1 minus alpha percent confidence interval for the difference in the population means, when the variances are equal, is as follows. This x bar, this is the sample mean for the first, the sample mean for the second, right? We can use the, well, I will show you. We can use the t percentile, but we can also use the z percentile. I will explain in a minute why. Sorry. Times SP right. This is the formula. This is the formula that I gave you in the lectures and also in the video. Now, here SP denotes the pooled sample standard deviation, which I will write down here, where SP squared, known as the pooled sample variance, is defined by right. So this is the formula that I gave you. But before I explain things, let me highlight this. In this formula, as you can see, I'm using the sample standard deviation. This is the sample variance for the first sample and the sample variance for the second sample, which we are not given, right? And also using the t percentile at this degree of freedom. Now, because if you go back to the question, the sample sizes involved are 150 and 200, which are pretty large numbers, right? I mean, certainly larger than 25, which is a nominal level in statistics. So, since they are very large numbers, we can approximate the t percentile with the standard normal percentile, and also you can take the sample variances, SA squared, SP squared, to be equal to the population variances which are given in the question, right? So you can say that this is approximately equal to the following. That's because of the large sample sizes. You can say this. Okay, where the SP squared is now given by this formula. Right, so the reason I'm saying this is because of the large because of the large sample sizes we can say this. So let me put this in a box. So this is the formula I'm going to use to answer the question. Right, so in order to use this, first we need to work out the SP squared. So let's try to do that. So SP squared is going to be Na minus 1, which is 149 times the population variance for the first sample is this. And for this is 90x squared divided by now if you work this out, this will be equal to 1105.6.32. Alright, that's the SP squared. Right, now the other things in this formula, we know what they are. Right, so let me call this was sake of star, right? So the star will become the following. It will become x bar A, which we know already is 1386 minus 1218 plus or minus, we are looking for 95%, so your alpha is 0.05, so that will be 1.96 times the square root of this, which is and then times this formula here, which is now if you do the math, this will be equal to, the lower limit will be 145.74 and the upper limit will be 190.26. Alright, so this is the answer to part 2. So you see what I've done, and this is the formula that I gave you in the lectures and also in the videos. But for this question, because of the sample sizes are large, like 150 and 200, which are really large in statistics, I have approximated the T percentile with the Z percentile, which is the standard normal percentile, and I've approximated the sample variances, this one and this one, by the population variances, which are given in the question. Right? Alright, so that completes question 2. Now let's go to question 3. So you have a population with this mean and variance. You have two samples. They are independent, and these are the sample means and these are the sample variances. Alright, so this is you have two different estimators, one for mu, one for sigma squared. Okay. The question is, show that both estimators are unbiased. Okay. Now, I'm sure you've done questions like this before, so it shouldn't be difficult for you guys. So this is part 1. So we want to show that both these estimators are unbiased. So let's start with the first one. Okay, bias of mu hat, which is, as you all know, is This is times x bar. Right. Now, taking the expectation inside, you get right. Now, the both samples have population mean equal to mu and population variance equal to sigma squared. So it's easy to see. I mean, if you want, I can show it. It's easy to see that both these are equal to mu, but I will show you it anyway. I will show it to you anyway. Alright, so if you take the expectation inside, we get times the expectation of xi Now we know that the expectations both are equal to mu, so this is going to be okay. Now the n and the m cancel, so what you get is 1 divided by n plus m. Now this is n times mu. And the same thing here, the m and the m cancel, so you get, this becomes m times mu minus mu. Alright, and this is clearly equal to 0. Right, so hence nu hat is unbiased for mu. Alright, now the second thing we need to show is that this is unbiased for sigma squared. Right, so let's see how we can do that. So we need to show that the bias of this is equal to 0. So this is going to be the expectation of taking the expectation inside, you get the following. Now remember that the sample variance with the 1 divided by n minus 1 or m minus 1 is an unbiased estimator of the population variance, which I mentioned in the class. So the expectation of that must be equal to this must be equal to sigma squared. Right? Okay, now if you sum these two, you get sigma squared minus sigma squared, which is 0. So hence, we have shown that this guy here is unbiased. It's an unbiased estimator for sigma squared. Alright, so that completes the first part of question 3. Now, the second part is to obtain an expression for the variance of mu hat and what happens when both n and m approach infinity. Alright, let's see how we can do that. Part 2. Okay. So we are looking for the variance of mu hat, which is the variance of taking the variance inside the brackets, you will get 1 over n plus m squared. Okay, so this will become m squared times the variance of x bar plus m squared times the variance of y bar. Now, the variance of x bar and y bar are easy to work out. I think I did this some time ago, can't remember when, but if you want I can do them again. This is the variance of x bar, which is 1 over n times the sum of xi, right? Plus m squared times the variance of variance of yi. Okay. Now taking the variance inside the brackets, you will get n squared times 1 over n squared times the variance of xi plus m squared times 1 over m squared times the sum of the variance of yi. Alright, these two guys cancel, so So you have the sum I from 1 to n of variance of xi is sigma squared. These two cancel again, so you have sum of sigma squared. Alright, so we are nearly there. So this becomes, this is n m sigma squared, and this is m sigma squared. So this will be sigma squared divided by n plus m. Alright. Okay, now as n and m approach infinity, this clearly goes to 0. As n approaches infinity, or m approaches infinity, or both. Right? I mean, it's sufficient for one of the sample sizes to approach infinity for this to go to 0. Okay. All right. So this completes question 3. Next question is question 4. So here we are trying to compare the population means for 2 different brands. So let mu A denote the population mean for brand A, right? And let mu B denote the population mean for brand B. So the test that we are interested in is the following. We are trying to test whether the population means are equal versus the alternative that they are not equal. Now, if you guys looked at my video on two sample tests, right? You will see, sorry, 2 sample confidence interval. You will see that the confidence interval 100 times, sorry, let me see, 100 times 1 minus alpha percent confidence interval for the difference in the 2 population means is given by the following. X bar 1 is the population mean for the first, sorry, the sample mean for the first population. X bar 2 is the sample mean for the second, plus or minus T 1 minus alpha by 2 with the degree of freedom of n minus 1 multiplied by SP, which is the sample standard deviation, multiplied by 1 over n1, the sample size for the first population, and n2, the sample size for the second. So this is the formula I gave you in the two sample confidence interval. The reason I'm using the T confidence, the T percentile and the sample standard deviation is because in this question here, we are not given the population standard deviation, right? The population standard deviation is unknown. We are only given the sample standard deviations for each population, right? Right. So this is. So let me put this in a box. Okay. Right, now let me write down what each of these things in the formula is. X bar 1 is the sample mean, right, for the first population, which is given to us as 21.8. Yeah. X bar 2 is given to us as 18.9. N1 is the sample size from the first population, which is given to us as 12. N2 is also 12. Now we need to compute this guy here, SP. Remember, SP or SP squared, let me compute SP squared. SP squared is given by the following formula, as you may recall. Here, S1 squared is the sample variance for the first population, and this is for the second population. So if you sub in the numbers that is given, 12 minus 1 is 11, multiplied by this for the first population is 8.7 squared, 11, multiply this for the second population is 7.5 squared, right? And this is divided by 12 plus 12 minus 2, right? It's going to be 22. Okay. Now, if you work this out using a calculator, you will get this to be 65.97. Okay. And we also need the percentile of the t-distribution. So we are looking for 95% confidence interval, so your alpha is 0.05. So this guy here will be t 0.975, your n minus 1 is 11. Now if you read this off the table for the t-distribution, which I showed you how to read, if you look at the video on t distribution, you will know I showed you how to read this. This will be 2.074, right? So hence the 95% confidence interval for the difference in the population means for the two brands is given by the following: 21.8 minus 18.9 plus or minus 2.074 times the square root of 65.97 times the square root of 1 over 12 plus 1 over 12. Okay, so if you compute this using a calculator, this is what you will get. You get minus 3.98 as the lower limit, and the upper limit will be 9.78. So this interval, as you can see, contains the value 0 because you're going from minus to plus. So it is possible that the difference between the two population means is not significant. In other words, it's possible that there is no evidence against the hypothesis that mu A and mu B are equal. Okay. So this is question 4. Now question 5, which is the last question on this tutorial sheet. Okay, so here we are interested in two different proportions, comparing two different proportions. So let P1 denote the proportion of registered voters who turned out to vote in California, right? And let P2 denote the proportion of registered voters who turned out to vote in Colorado, CO. Okay. Now we want to see whether the difference between these two proportions is significant or not. So the question in this case is to find a 100 times 1 minus alpha percent confidence interval for the difference in the two proportions. Now if you look at once again my video on two sample confidence intervals, you will see that the formula that I have given you is the following. Okay, this is the formula in the video, and also is in the lecture notes, printed lecture notes, and also the handwritten lecture notes. Right? Now in this formula, x bar 1 is the sample proportion for the first population, and this is the sample proportion for the second. N1 is the sample size for the first. N2 is the sample size for the second, and this is the percentile of the normal distribution. Okay, so let's write down what we are given. We are told that N1 is equal to 288. We are told that N2 is equal to 216. X bar 1 is the sample proportion for the first population. So according to what we are given is 141 divided by 288. X bar 2 is 125 divided by 216. Right? And we are looking for 95% confidence interval, so your alpha is 0.05, so this will be 0.975, and this will be 1.96. Right? So we have everything we need, so we can sub them into this formula and find the 95%. So hence the 95% confidence interval for is the following. Right, divided by N1, which is 288, then (125) divided by 216, 1 minus of that, divided by 216. Right? Now if you work this out using a calculator, you will get the following. You will get the lower limit will be minus 0.177, and upper limit will be minus 0.0015. So in this case, the confidence interval does not contain the value 0. So that means possibly that the two proportions are significantly different from each other. right? That's the proportion of voters turning out to vote in California and the proportion of voters turning out to vote in Colorado are probably significantly different from each other. So this completes the video solution for this tutorial.